In this video, we'll discuss quadratic and polynomial inequalities. So this particular skill is going to be very important in your calculus class, so I encourage you to follow the process that I show you here, even if you know how to do it a different way. So first of all, what we're going to do is make sure that we have a 0 on one side of the inequality symbol. If it's a quadratic or even if it's a polynomial, we're going to factor. We're going to find the zeros of the quadratic using the zero product rule as if it were an equal sign. Even though it's an inequality, we're going to pretend it's an equal sign. When we find those are called our critical points, and they'll separate our number line into different intervals. We're going to mark our critical points on the number line. We're going to use an open circle if it is less than or greater than, and a colored in circle if it's greater than or equal to or less than or equal to. And then we're going to identify our intervals in interval notation. Then we're going to choose a test point, and then we're going to decide if that test point makes the inequality true or false, and then choose the intervals that make equality true. So I'm going to start with a really simple example here. I'm going to start with x minus 3 times x plus 2 is greater than 0. So in this particular case, we do have a 0 on one side of the inequality, and it is already factored. So if this were an equal sign, then I would use the zero product property and say either x minus 3 is 0 or x plus 2 is 0. And I would get my two zeros, which are x equals 3 and x equals negative 2. These are my critical points. So I'm going to put those two critical points on a number line. So I've got 1, 2, 3, and I've got negative 2. And because it's strictly greater than, no equal to, we're going to put open circles on these. So we can see that these 2 points separate this number line into basically 3 different intervals. And those intervals are negative infinity up to negative 2, negative 2 to 3, and 3 to infinity. And what I want to do is find a test value. So the test value can be anything that is in the interval. So for negative infinity to negative 2, I'm going to test negative 3. And when I plug negative 3 into this inequality, you'll notice I'll get negative 6 times negative 1, and that's positive. So this whole interval here, anything in that interval would give us a positive result. For the next interval from negative 2 to 3, I'm going to test 0. And that's going to give me negative 3 times 2, which is going to be a negative result in here. And then for this last one, I'm going to choose 4. And when I plug 4 into this inequality here, I get 4 minus 3, which is 1, 4 plus 2, which is 6, and I get a positive result again. So then I ask myself, well, I wanted it to be greater than 0. Another way of saying greater than 0 is positive. So my solution is going to be these 2 intervals where I got a positive result. So negative infinity to negative 2, union 3 to infinity. So as long as we follow that process, we'll be able to do quadratic inequalities and also larger polynomial inequalities. So let's take a look. Here's another example. Here we have, if I imagine this is just an equal sign, I get the 2 critical points, x equals 1/3 and x equals 2/5. Also, this is greater than, so I know I'm going to have open circles here. So here's 0, here's 1, here's 2. So let's see, 1/3 might be about here, 1/3, and 2/5 might be about here. It's not very they're pretty close together here. Okay, so our intervals. For our intervals, we've got negative infinity up to 1/3. We've got 1/3 up to 2/5. And we've got 2/5 to infinity. We're going to have some test values. It's helpful to look at your number line here, so we can choose 0 for this first test value. That's going to give me -1 times -2, or a positive result. Between 1/3 and 2/5, well, 1/3 is 0.3 repeating, and 2/5 is 0.4. So I think I'm going to choose 0.35. And when I choose 0.35, I'm going to get a negative result. And notice, I don't really care what the number is. I just want to know if it's positive or negative. And FYI, one nice way to do this is if you put this into y1, this piece here, just like this, and then use second function calculate, you can plug these values in and decide right away if they're positive or negative. So you're going to second calculate a value. All right, so 2/5 to infinity, I'm going to choose 0.5, and 0.5 is going to give me a positive result. So again, in this case, I want to be greater than 0 or positive. So my solution is negative infinity to 1/3 union 2/5 to infinity. All right, we have one last example here. This one is different for a couple reasons. One, I've got this equal to bar, so I'm going to have some solid circles and some brackets. And two, the polynomial, or the quadratic in this case, is not factored. So I'm going to start by factoring this polynomial. So I'm going to do 4 times -3, which is -12. So I'm going to list my factors of -12, 2 and 6 and 3 and 4. And I notice right away, +1 and -12 will get me that -12 and the -11 in the center. I'm going to divide through by this lead coefficient, which is 4, and I'm going to get +1/4 and -3/1. So this is going to factor for me as, remember, we bring these up, 4x plus 1 and x minus 3. Equals less than or equal to 0. So we get, for our critical numbers, we're matching that's an equal sign. We get -1/4 and 3. So here's our 0, 1, 2, 3. This is less than or equal to, so this is going to be a solid dot. And then -1/4 might be in here. So our intervals, and we're going to have our intervals, our zeros, and then whether or not it's positive or negative. So our intervals in this case, negative infinity to -1/4, bracket here, right? -1/4 to 3, bracket, and then bracket 3 to infinity. So in here, I'm going to test -1. That's going to give me, if I plug it in, I like to plug it into the factored form because it's easier for me to see if it's going to be positive or negative. I'm going to get a positive result. If I test 0, I'm going to get a negative result. And if I test 4, I'm also going to get a positive result. In this case, I want it to be less than or equal to 0, which was in this region. So my solution is -1/4 to 3. Now, I find it necessary to point out the 3 that I did all had positive, negative, positive. These signs here don't always alternate, so be very, very careful. Don't make the assumption that they're going to alternate. That concludes this video on quadratic inequalities. And of course, we can use this for polynomials as well. I suppose if you had, for example, x minus 1, x plus 1, and x minus 2, then you would just have 3 critical points and 4 intervals, and you just have to test each one.